Welcome to Brainbox Notion. Today we are diving into the fascinating world of railway track construction. Building a railway track is a complex and precise process that requires meticulous planning and execution. But with our Planswift template, you can accurately take measurement in less than 5 minutes. So in this video, I'll walk you through each step of railway track construction process using Planswift from initial planning to final execution. So hit that subscribe button and stay tuned. If you are new here, make sure you check out our previous video on road construction and building works. So let's dive in. So this is our design that we are going to use for this tutorial. I'll leave the link in the description to download the drawing so that you can follow along. For those who have the template, all you need to do is to go under civil and heavy engineering works. We are done with road. Today we are going to treat rail track construction. Our next video is going to be on airport, so make sure you subscribe so that you don't miss out. And if you still don't have the templates, you can check the link in the description to get your own copy so that you can follow along. So under rail construction, we have earthwork and the rail track. But before that, before we start our takeoff, let's go through the drawing and see the rail components. So here is the design. Let's go through the details first. So here we have the track details. We have our sleepers, which is concrete size 2.75 by 0.23 by 0.15. So this is sleepers. So here we have the sleepers. This is the sleepers. As you can see, this concrete here is the sleepers. So and the next one, we have the sleeper spacing, which is the spacing between each sleepers, which is 1.5 meters. Yeah, the spacing between each one here is 1.5 meters for the design we are going to use. Then the next we have the bullhead, which has a mass of 30 kg per meter. So we have the hull types here. So here we have the flat bottom rail, we have the bull-headed rail, and we have the double-headed rail. So we are going to use the bull-headed rail for this tutorial. Then next we have the fish plate. So here is the fish plate. Here's the fish plate here. As you can see from the design, there's the fish plate. So next we have the bolts, which I think we have the bolt here, and we also have the bolt here. And the next we have the fasteners. So the fasteners, here's the fastener. As you can see, this is the fastener. So that's all for rail. Here's a typical railway station. As you can see, we have the track, we have the fasteners, we have the sleepers, and so on. So let's go back to our drawing now. So in here now, in the drawing, we have the rail track layout and we have the section. So in the section, when you look at the section, you can see that we have bottom ballast, we have the top ballast, and we have the sleepers, and we have the rail and the shoulder here. And under the layout, we have the sleepers, which the spacing was given to be 1.5, and here is station A. And from station A to station B, here it is 28 kilometer. So you can see it's 28 kilometer, which is approximately 28,000 meters. So each 1 kilometer is 1,000 meters. So our measurement is going to be in meters. So if you want to convert it to kilometer, you know how to do it, but we are going to measure in meters. So here we have 28 kilometers. And here we have the spacing for the rail to be 1.345. The drawing is not clear, but it is manageable. And we have the shoulder here. So for this takeoff, we are going to assume all earthworks has been done, because we have treated earthwork under road and pavement. So if you have not watched the video, you can go back and watch the video for road and pavement. And for cutting and filling, in case if your design has cutting and filling, so you can also refer back to road construction the same way that you can do your cutting and filling to take your levels. But here we are assuming all level to be flat, all earthworks are done and everything. So we are just moving straight to the railway track construction without earthworks. So if you still have issues with earthwork, you can refer back to road and pavement to check how to do your cutting and filling. Let's move straight to the takeoff. In here now we have the rail track. So under the rail track now you see bottom ballast, top ballast, the rail track, that's the track itself, this in tonnage, and also the sleepers and the fish plate and the fasteners. So these are the items that we are going to measure. I love civil engineering, just few items of work to measure. Within 2 minutes, you are done with your rail construction, but with large quantity. So let's begin our takeoff. So under here now, the bottom ballast, as you can see, this is the bottom ballast. And this drawing now, we have half here. So we are going to divide this bottom ballast into section. So let's divide it like this, linear, from this point to this point, and also from this point to this point, and also from this point to this point, and also from this point to this point. So this is how we are going to divide our bottom ballast and top ballast into section. So as you can see, there's some little write-up which is not clear. So it is divided as section A, and this is section D, this is D, and this is B, and also this is B, and this is C, and this is C. But it is not too clear. So in here now for section D and D here, but we are starting with bottom ballast. So for section D here, our width is going to be 2.75 plus 0.5 plus 0.5, which is going to give us 3.5 meters. Then in here now, the length for this side is also given to be 0.4, and also the length for here is also given to be 0.8. But the figure are not too clear, so that's why I try to sketch it with this. As you can see, here we have 0.8 and 0.4 for the both side, 0.4, 0.8. So let's start our takeoff. So when you click on bottom ballast, you have this. So you are going to specify the track and the length of track, the track mass, the ballast width, ballast depth and side, which is for this section, any section that you want to start with. Then we have another one for section A, which is ballast width, ballast depth, and the side. Then we have another one too for section B, the width, the depth, and the side. So here is the triangular section, which is 1, 2. So I don't think there will be any design that will be given to you that you have to divide your bottom ballast more than 5 sections, because we have 1, 2, 3, 4, and 5 section. So in here we have only 1, 2, 3 section. So I don't think there will be any design that will exceed this number. So on our top ballast we have only 2 sections, 1 and 2. So let's start. So first you have to specify your track length. which we said it is 28 kilometer. So 28 kilometer now is 28,000 meters. And the track mass was given to be 30. We'll go back and check. And the ballast width for this section D, we said it is 2.75 plus 0.5 plus 0.5, which is going to give us 3.75. And then the depth is 0.4. As you can see here, this is the depth, 0.4. 0.40. And the number of side, this is only one side. So we'll click 1. So for the next one here, which we said it is 0.4, we have 0.40 by the depth, also 0.4 by 0.40. And this is by two sides. We have 1 and 2. So we'll click by 2. So this next one now is the triangular section. So we are not going to book it here. We are going to move to this other section, this triangular section, and we have our dimension to be, the width to be 0.80 and the depth to be 0.40, and it is also by two sides. So you click by 2. So that's all. Then you click OK, and you just click once on the bottom ballast. So that's all for bottom ballast. So the next now, we have the top ballast. So you are not going to pick again from your templates. All you need to do is just go back to your takeoff summary. So under your takeoff summary, you will see all your sub items here, all your sub items here. So we have the top ballast to be 0. We have the rail track in tonnage to be 0. We have our sleepers to be 0. But our fish plate, we have our figure for our fish plate because it is already linked with the length of the rail track. As you can see, our fish plate, it's on the rail track, so it is automatically measured. So as you can see, the fish plate is on the rail track, so you use the length to get the number of fish plates. So since the length has been specified, so the template will automatically take off for the number of fish plate needed for you. So we'll come to that and explain more. So let's go back to bottom ballast. Let's go back to our drawing. So this is the drawing. So now for the top ballast now, let's go back. So the width we said for the top ballast 2 is going to be 3.75 for section D also. So we double click on this, as you can see. When you double click, you specify. Let me put it here so that you'll be able to see. So section D is 3.75, and the width, the depth, sorry, for this is, sorry, I can't move it. The depth is 0.2. So let me go back. The depth is 0.2. So 0.20, and also by one side. So click 1. So the next one now is the triangular section. So we don't have any other normal section. So we'll move back to triangular section. So under triangular section, we set the width to be 0.4, which is 0.40, and also the depth to be 0.2. 0.20, and by two side. You have this to be by two side, 1, 2. So click by 2 and then click OK. So this is the top ballast quantity. So the next one now is the rail track in tonnage. So you double click, you go to form. So in here now you can see you have the track length, you have the mass weight. So what you just need to specify here is the number of rail track, which is two number, which is 1 and 2. So you click two number and click OK. And this is the total weight of the rail in tonnage. So if you go back now, you see that you have your track length to be 56,000 meters, which is 28,000 times 2. So you click OK. So the next one now is the sleepers, which is, let's go back to the drawing, which is this. This is the sleepers. Go back. So you double click on the sleepers. You click on form to have a better view. So we set the spacing for the sleepers, it is 1.5. Let's go back and confirm from the details. As you can see, sleeper spacing to be 1.5. So go back and specify, double click, sleeper spacing 1.5, then click OK. So as you can see, the moment you specify the spacing for the sleepers, you have your fasteners, because these fasteners are the quantity for fasteners are related to the number of sleepers. Yeah. Let's go back to drawing and see. As you can see, these are the fasteners. You can see fasteners. So where you have your sleepers, you have a fastener there. So the moment you specify the spacing, you automatically get the number of fasteners. So let's go back. So for this fish plate now, when you double click, you see that you have an average length of track to be 12 meters and the number of pairs to be 2 numbers. So when you change this average length of a single track is 12 meters. So whenever you change this length, the number will change automatically. Let's say, for example, the one we have, the one given is not up to 12 meters, maybe it is 10 meters. When you click 10 meters and click OK, you can see the figure will change, but 12 meters is the average length. Let's take it back to 12. So in here, you can change the number of pairs you want and also the average length of trunk given to you. And for the fasteners, when you double click, you see we have by two side, two number, this side to be 2. So you can also change the number 2 here to adjust the quantity and change it to be by 4. You can see the figure has changed. I'll leave it by 2 and click OK. So in here now, for the sleepers, we have sleepers, the total quantity. This sleepers is in concrete. So we have the sleepers, the total quantity. Let's say it's a precast. So you want to know the total cubic meter you want to cast in order to get this number of sleepers. We have it here. So there are other materials that you can use for the sleepers. Some use timber and some use steel, but the most common one is concrete. So in here now, if you want to find the cubic meter of concrete needed to precast all these sleepers, so all you need to do, let's go back to the sleepers details. So as you can see, the sleepers concrete size is 2.75 by 0.23 by 0.15. So when you go back, you double click. So you click on form to have a better view. So here now you have 2.75 by 0.03 by 0.15, and then click OK. You can either use timber or steel, but the most common one used is concrete. So if you have timber, depending on the material you are going to extract your number of sleepers in, so you divide and do your pro rata. Also, if it is steel, it depends on the length of the material you are going to use. If it is also 12 meters or it comes in 3 meters, so you multiply it with this to get the total number of sleepers, total meters needed, or total tonnage needed when you do your pro rata from the number of sleepers, depending on your material. So you do your pro rata and get the actual meter or tonnage you want to use, or if it is timber, you get the number of material that you need to extract your sleepers from. So basically, that's all for rail track. So in our next video, we are going to be treating airports. So if you notice here in our design, we have culverts. We have 3 culverts, 1, 2, 3. So we are not going to be treating the culvert here. You can refer back to road construction to see how to measure the culvert too. So our next video, we are going to be treating airport construction. So that's all for rail. So thank you for listening, and make sure you subscribe so that you don't miss out on our next video.